let's integrate from 0 till 0.1 dx all over the square root of 1 minus x squared. Looks a little bit challenging, but let me rewrite it just a little bit, and maybe you'll recognize something. Isn't it the same as 1 over square root of 1 minus x squared dx? Do you recognize this function? You've seen it before. Maybe you even took a special exam where you were practicing derivatives. Don't worry if you don't recognize it. I have a whole massive cheat sheet for you over here. Those are derivatives of the inverse trigonometric functions. And we ask you to memorize derivative of arcsine, arccosine, and arctangent, even though there are more. So I remember it this way. The derivative of arcsine is 1 over square root of 1 minus input squared, and I'm saying it out loud. 1 minus input squared. Cosine has a negative in front, but everything else the same. Arctangent is the best one. Doesn't have the annoying square root, and it's also plus in the denominator. The function we see in front of us is 1 over square root of 1 minus x squared, and it is inside of the integral. So let's write it down. The result of this integration will be arcsine of x. And now put parentheses, and instead of plus c, you put a bar, 0 and 0 plus 0.1 equals 2. You don't have to grab your calculator, put it back. Just substitute the top, the upper limit of integration. Substitute the bottom, the lower limit of integration, and find a difference between these two. Now you just need to remember what is arcsine of 0. And the answer will be, just keep it as it is the exact answer. Arcsine of 0.1 minus what? Correct, 0. How do I know? Because I need to answer the question. 0 sine of what angle gives me 0? Even though there are many answers, not just 0, but also pi, minus pi, 2 pi, and so on. We are working on the restricted domain, which is pointed out over here. On this domain, only 0 works. So arcsine of 0.1 is the final answer. I was kind of curious how this integral looks graphically, so I decided to plot the function inside of the integral and see how it looks from 0 and until 0.1. Oh, this is how it looks. So this is the function 1 over square root of 1 minus x squared. Do you see two vertical asymptotes at minus 1 and 1? Here they are, two VAs. And also it has a global minimum and so on and so on. So we were asked to find the area from 0 to 0.1. Well, it's very tiny area. It's from here to over here. So this is the area we're looking for, and we found it as the exact answer of arcsine of 0.1. So I expect this number to be very small. And I wanted to show you that if you plug it into a calculator, it's indeed a very small number, which is 0.100 and then 167. So it matches our understanding of the application of the integral as area below the graphs. And there are more applications than that. And that's how you work with inverse trigs. Try always to visualize what you're doing. It will help you in the future in engineering and physics classes and in general of understanding of what you're doing mathematically. Good job for working hard.